We're going to wrap up our introduction to the basic notions of logic, first by learning a technique for proving an argument invalid, and second by covering a few additional logical concepts you'll need to know. By the end of this lesson, you should be able to construct your own counterexample, and you should have a good grasp on these additional logical concepts we introduce. In our brief study of syllogistic logic in the previous video, we covered a few simple valid argument forms and how to construct valid arguments from them. What we haven't gotten to yet, and won't for a couple of weeks, is how to prove that an argument is valid. But what we will look at now is a way of proving arguments invalid. So remember that an invalid argument is one with a form such that it is possible that the premises are true and the conclusion is false. So a counterexample is any substitution instance where the premises are true and the conclusion is false. That's exactly what we needed to show that an argument was invalid. So a counterexample shows it's possible for an argument form to have true premises and a false conclusion. It's important to note, just because you haven't thought of a counterexample, that doesn't mean the argument is valid. It might just be hard to construct one. But it is the case that valid arguments can't be given a counterexample. So if you can construct a counterexample, then you've shown that an argument is invalid. So how do we construct a counterexample? First, let's start by looking at a sample concrete invalid argument. No professors are children. Some students are children. From that, this argument concludes that some professors are not students. In this argument, both of the premises are true. Professors aren't children. Some students are children. And the conclusion is true. Some professors aren't students. But true premises and true conclusions, remember, that's not enough to show that your argument's valid. Remember, to show validity, we have to show that it's impossible for the premises to be true and the conclusion to be false. What we're about to show is that it is possible for the premises of this argument to be true and the conclusion to be false. And we can show that by constructing a counterexample that has the same form as the original concrete argument. So that's why we have in the middle here the form of the argument. So this argument has the form no x or y. So x was professors and y was children. Some z are y. So z is students. And then from that, the argument concludes that some x are not z. To construct a counterexample, we need to make up a substitution instance that makes the premises true and the conclusion false. So we need to come up with terms to substitute in for x, y, and z such that the first two statements are true and the last statement is false. And in the bottom, we have such an example. No cows lay eggs. True. Some mammals lay eggs. True, marsupials do. Some cows are not mammals. That's false. So we have two true premises, but a false conclusion. That proves that this argument is invalid, and that argument form is invalid. In that counterexample, the premises are a proper substitution instance with cows for x, lay eggs for y, and mammals for z. And it's a substitution instance that makes the premises true but the conclusion false. So constructing a counterexample with the same form as the original argument shows that the original argument was invalid. In the original argument, even though all the statements were true, those premises didn't justify that conclusion. So a bunch of true statements does not a good argument make. So to repeat, the steps for constructing a counterexample to a concrete argument are: first, figure out the form of the argument. Then, construct a uniform substitution instance that makes the premises true and the conclusion false. Our goal in constructing a counterexample was to prove that an argument was invalid. Validity and invalidity will be our main focus when we study deductive logic. But there are going to be a few additional concepts that it's really worth knowing. And we'll come up with tests for these concepts just like we do for validity and invalidity. So we're going to start by contrasting joint possibility and impossibility. Two or more sentences are jointly possible when it's possible for them to be true in the same circumstances. So this is a concept that applies to sets of statements, two or more. And we say that they're jointly possible if all the statements can be true together. So here's an example of some jointly possible statements. Iris is a novelist. Iris is a philosopher. There's no reason these statements can't both be true. One or the other might in fact be false. What do you know about Iris? But the important thing for joint possibility is that they can both be true. Contrast that with joint impossibility. Two more statements are jointly impossible when they can't be true in the same circumstances. So the next two sentences are jointly impossible. Iris is older than Elizabeth. Iris is younger than Elizabeth. It's not possible for one person to be both older and younger. So these two statements can't ever be true in the same circumstances. So either it's the case that Iris is older than Elizabeth, or it's the case that Iris is younger than Elizabeth. But only one or the other can be true. The two concepts we just contrasted were for multiple statements, two or more. The next three concepts apply to a single statement. The first one is the idea of a necessary truth. So that's a statement that's true in any circumstances, one that's impossible to be false. So these tend to be kind of unnatural sounding ones because the most interesting truths aren't the ones that are necessarily true. An example of a necessary truth is if most birds fly, then most birds fly. No matter what the world is actually like, if most birds fly, then most birds fly. This statement is true. We can contrast statements like that with necessary falsehoods, ones that are false no matter what the circumstances are, ones that can't be true. An example of a necessary falsehood would be all birds fly and no birds fly. So if all birds have some trait, it's impossible for them also to all not have that trait. So this sentence just can't be true. There's no way to imagine circumstances where it could be. Necessary truths and necessary falsehoods are outliers. Most statements are contingent. Either they're true, but they could as well have been false, or they're false and could as well have been true. So a contingent statement, it's one that may be true or false depending on the circumstances. For example, 50% of Rutgers professors are aliens disguised as humans. This statement is false. You probably find it pretty implausible. But there's nothing illogical about this statement being true. It could be true. We can imagine circumstances where it is true, it just happens to be false in the world that we live in. So this is a contingent statement. One of the things we just considered was the potential for a single statement to be necessarily true. There's a kind of nearby concept for multiple statements. So we're looking at another concept that applies to sets of statements. And that's necessary equivalence. Two or more sentences are necessarily equivalent when they're either true in all the same circumstances or false in all the same circumstances. For example, if it's fall, then it's a good time to grow broccoli. If it's not time to grow broccoli, then it's not fall. These two statements are necessarily equivalent. If you imagine circumstances where one is true, the other has to be true. And if you imagine circumstances where one of them is false, the other has to be false. They're true and false together. Going forward, we'll learn not only how to prove that arguments are valid, but also how to show that a statement or a set of statements has one of these logical properties. So they're important to remember for that reason. And that wraps up the material for the first unit of this course. So by the end of this first lesson, all 5 videos, you should now know what distinguishes arguments from inferences and what the key elements of arguments are, like statements, premises, and conclusions. You should know what makes an argument inductive or deductive. You should know how to distinguish the form of an argument from its content and how to substitute terms or statements for variables. You should be able to construct a counterexample, and you should have a basic grasp of how to apply the logical concepts of validity and invalidity, soundness and unsoundness, joint possibility and impossibility, necessary equivalence, necessary truth and falsehood, and contingency.